Okay, so on the other hand, I have here my remote client. I've connected to PSDaint using what we've seen last time. What I'm going to do is I'm going to activate CUDA debugging, and I'm going to activate the memory debugging for GPUs. So I'm going to track GPU allocations, also CPU allocation. I'm going to activate the memory debugging here. So I'm ticking all these boxes to make sure that if there is a memory error on the host or on the GPU, Allinea DDT will find it. So once this is configured, click on OK. I'm running the job, and I have the job already running here on Allinea DDT. So basically, this is approximately where we left it last time. So based on this, so you know the graphical interface, we have all the control buttons, and at the moment, I am looking at the C part, so the host part of my application. I can look at the variables, I can look at a lot of things. Now, what we want to do is, because this is a GPU code, we want to make sure that when a kernel is started, I'm going to stop the execution. So if you go to the control default breakpoints menu, you see here an entry called stop on CUDA kernel launch. This means that as soon as I'm going to hit a CUDA kernel, Allinea DDT will stop the execution and ask me what I want to do. Do I want to continue, or do I want to pause the code, this kind of stuff. So I'm going to do it. I'm going to click on play. So my code is running. And now I can see a small message saying me, okay, I have started a CUDA kernel in mmult kernel, so I have the line of the code and everything. So I still want to see these messages, and I'm going to pause the execution because I want to look at what is happening inside the CUDA kernel. So there are a few things that you need to know. Okay, I know it's taking a long time. There we go. Okay, so now I have my kernel all good and started. I'm going to pause this. So you need to know that you have two different contexts when you're doing GPU debugging. First of all, because you have two different debuggers, really. On the CPU side, you have a debugger which is attached to the host part. But on the kernel, you have a different debugger which is looking at what is going on inside your GPU kernel. So what I'm looking here is those two different contexts. If you go to the stack window here, you can see those two different things. Here, if I'm looking at the main entry, I am on the CPU side. I can see I have one thread and I have 0 CUDA thread. Okay, so this is the CPU. And you can see also that if you're clicking on the top, I'm looking to my thread number 1. And if you look at the variables at the data, all of them are declared on the host. So for instance, this nproc variable, this is on the host part. Now, if I want to see what is happening inside my GPU, I just have to click here. So if I click on this bit here, now I'm looking at what is going on inside my kernel. And if, for instance, if I select this line, I'm looking here at variables, at sizes of data that are all on the GPU. So I'm inspecting the variable inside the kernels. I can look at the content of data of arrays inside the GPU kernels, and I can control these kernels. You can see here that the K3 kernel here is activated. It is pink, which means that this is what I'm controlling right now. And if I click on step, basically, if you look at the stack, 32 threads have moved forward. So this is a warp. This is the minimum amount of threads that I can play at the same time. And again, what you can see here is I can look at variables, I can look at a lot of different things. Now, what I want to do is to crash my code, right? I know there is an error. I want to check what is happening. So if I play my code, at some point, I get this error message saying that my kernel has stopped in a function with a lane illegal address. So when I have this message, I have two different choices. I can continue the execution or I can pause it. All of this is happening inside my GPU. If I continue, because there is an error, there is a good chance that my whole code will crash and I will lose my debugging session. I don't want to do this. I want to keep the possibility to look at variable, to look at data. So I want to pause my thread. And what we see is that Allinea DDT has highlighted the line that failed. And if you look at the logbook, again, you will see the error message, you will see the location of the stack, you will see the variable, everything is recorded in the logbook. So in this line, something has gone wrong, okay? My code has crashed. So there are not many variables that are available here. There are only a few things. So if I want to look at what is going on here, I have, for instance, this data here, so this index. I want to look at it. I can see the value here, so it's approximately 32,000 something. So what is going on? How do I detect what's going on? So what I can do is use my evaluation window, the top bottom right corner, and I would like to add an expression to understand what is the block I'm trying to access. Okay. So now basically, if I want to restart my session, I can play the code and everything will work successfully until the end. So you can notice that all the expressions that I wanted to evaluate earlier, they are still here, they are still present. So I'm keeping the same debugging session, breakpoints, trace points, everything is kept from one session to the other. Okay. One other thing that I would like to mention is that for this particular example, you have seen that there was a problem in the size of the data on the GPU and the host, which triggered the problem. And basically, the application crashed when we were doing a memory overflow. And this is possible because I activated the memory debugging. So again, we will have a more in-depth memory debugging webinar in the future, maybe next month. But just quickly, you can change memory debugging options before starting the job, but you can also change them at runtime. So let's say that, for instance, now I would like to change and have a more balanced memory debugging. I can change this whenever I want, as soon as the code is stopped. So we have two different mechanisms. We have a heap debugging, which basically adds checks and forces errors when you're trying to debug your application, so such as this one. So you can change this. You have more information in the small user guide if you click here. And basically, every time you move this little thing, you can see that there are keywords appearing in the checks here. And these keywords basically activate memory debugging features. The other memory debugging option we have is heap, overflow, and underflow detection. These are guard pages, which means that every time you do a read or write before or after allocations, DDT will stop the execution. And in this particular example, this is the feature that actually stopped the execution when we were doing our illegal memory access. Okay. Another thing I didn't mention when we were doing this small exercise was about the kernel progress view. So when we are starting the code and that we start a kernel, you can see here that on the GPU side, you have this kernel progress view tab that shows basically the advance of the kernel. So how far am I in the kernel? How many threads have been scheduled? How many threads have run to completion? So all of this is available in this little view. So as soon as this gives me control again, so I'm going to pause this. Not a problem. Okay, so basically these are really the key aspects that you need to know about GPU debugging. Looking at different data in different contexts, moving through the stack being able to control warps. You can also control different things if you want to control a block. Instead of stepping CUDA threads, you can also step CUDA blocks or the whole kernel if you want to. The warp is just the smallest amount of threads that you can step at a time. The kernel progress view, when it works, tells you how far the kernel has been executed. The logbook shows you everything, including on the GPU. So if you're looking, for instance, when I stepped here, these were the variables on my GPU when I was first clicking on step. So all the data is entirely available. But basically, everything you see here, this is using a CUDA kernel. If you're using an OpenACC kernel with a Pragma, Shard Pragma, ACC something, you will have exactly the same thing. You will be able to browse your kernels here in the run dialog. You will be able to step the same way warps or the whole kernels at the same time. There's absolutely no difference whatsoever in Allinea DDT. It's completely seamlessly integrated. Do you have any question about what we have seen? If you have any question, please send it in private through the chat to myself or Jean-Guillaume, or otherwise you can also just unmute a microphone. That works too. No question? All right, so if there is no question, I think that we can wrap up.